even though number 2 was an extra credit problem, I thought it would be good to kind of cover it because number 2 is based on number 1, and that's exactly what it said. It said, using the result from the previous problem, identify all of the real zeros of the equation. So this was my polynomial, and I factored it out as far as I could factor it. So I have several terms here. Any one of these terms, if they are a 0, makes the whole thing equal to 0. So clearly for this one here, if x is equal to 0, then my whole thing is going to be equal to 0. So that term right there I've taken care of. And this one here, the answer is -2. If x is equal to -2, then that's a 0. Now, this one here, I don't know what a 0 is going to be for that. I mean, I know it's certainly not factorable in the normal sense of the word. So what I did was I said, well, what's the discriminant? So the discriminant, as you recall, is the part under the radical sign in the quadratic formula. So the discriminant is b squared minus 4ac, and I'm just doing it for this quadratic part right here. Okay, so b squared would be -2 squared minus 4 times 1, which is a, times 4, which is c. Well, this gives me 4 minus 16, which is equal to -8. So I know that because it's a negative number, I am not going to have any real solutions to this quadratic. So this one here, there is no answer to that. There is no 0 associated with that term. It is not real. This one here, though, x cubed plus 3, let's set it equal to 0. So I have x cubed plus 3 is equal to 0. X cubed is equal to -3. Now, if the power of x was even, then this would be an imaginary number, wouldn't work. But it's not. It's odd. So I can actually go ahead and take the cube root of this and the cube root of that. And I would wind up with x is equal to the cube root of -3. And if you think about it, that is in fact a real number. And if you think about it on a graph, how can we have a cube root of a negative number? Well, if we recall, the graph of a cube root, so if I had x is equal to 1, my cube root is 1. And if I have x is equal to 8, my cube root is 2. And if x is equal to -1, my cube root is -1. And if x is equal to -8, my cube root is -2. So the graph of my cube root looks something like this. That is my cube root graph. But the key part here is, what's a cube root asking for? A cube root is saying, is there a number, when multiplied by itself 3 times, will give me the number underneath the radical sign? So, for example, the cube root of 8 is equal to 2, because 2 times 2 times 2 equals 8. Well, what about the cube root of -8? Well, that's equal to -2, because -2 times -2 is +4, times -2 is equal to -8. So you can have a cube root of a negative number. You can have any odd root of a negative number. So that's why it was an extra credit problem. But this is an actual answer. And if you plugged it into your calculator, you would get an answer. Why don't we just show that here? I'm going to go. -3 to the 1/3 power. I think in parentheses 1 divided by 3. That's our cube root. And I get the answer of -1.4422, blah, blah, blah. It's an irrational number, but it is a real number. And just to show you, if I did -3 to the 1/2 power, so I take the square root of -3, it's going to give me an error. Uh-oh. It's not supposed to do that. Okay, well, forget about the calculator part. It's okay to do it with a cube root. That's very odd.